Welcome back. We're going to talk some more about solving systems of linear equations. Here is our system. We have two equations, each in two variables, x and y. So these are linear equations, x to the first, y to the first, and all that. So we're going to solve this system twice, actually, just to show you it can be done in more than one way. But this is solving by substitution. Both will be solving with substitution. We're going to start by noticing that y equals x plus 4 is a nice, neat equation where y is all by itself. So anywhere we see a y in the other equation, we can replace it or substitute the y with x plus 4, because x plus 4 is y, equals y. Okay, so we'll rewrite our first equation with x plus 4 wherever we see a y, and that'll look like this. 12x minus 5 times, instead of y, x plus 4. X plus 4 equals negative 20. Now, we have a new equation with only one variable, x, so we can solve for x. Let's do that. We'll distribute negative 5 across this addition here. That doesn't change our 12x, so 12x minus 5 times x is minus 5x. Minus 5 times positive 4 is minus 20. And all of that equals negative 20. Now we can add 20 to both sides of the equation, and we'll get 0 here, 0 there. We can combine the x's. 12x minus 5x is 7x. So we get 7x equals 0. Well, the only thing you can multiply by 7 to get 0 is 0. X equals 0. Okay. Now that we know that x equals 0, we can take that and plug it in, or substitute 0 for x in the original first equation, or in the second equation. Actually, we want to do both of those things to confirm that that is truly the x-coordinate of the solution. So we'll say 12 times 0 minus 5y equals negative 20, and we'll solve. Well, this is 0. Negative 5y equals negative 20. If we divide by negative 5, we get y equals 4. Negative divided by negative is positive. 20 divided by 5 is 4. And we get y equals 4. Now we'll use the second equation. Y equals x, which is 0, plus 4. Well, 0 plus 4 is also 4. So both of those give the same result, so we have confirmed that x equals 0 is the x-coordinate of our solution, and that it corresponds with the y-coordinate 4. So we know that this one's solution is 0, 4. Now, that's all you have to do, but I'm going to do it another way just to show you that you don't have to substitute some expression for y. You can substitute some expression instead of x. Okay? So if we rearrange this equation so that we have solved for x, we would get x equals y minus 4. Subtract 4 from this side of the equation, leaves us with x all by itself. If we subtract 4 on the right side, we have to subtract 4 on the left. And then I just flip-flop the sides of the equation, which is always acceptable. So here we have this statement, and we can make a substitution. Anywhere we see an x here, we can replace it with y minus 4. Let's do that. So 12 times, instead of x, we're writing y minus 4, minus 5x, 5y, minus 5y equals negative 20. Okay, so we substituted y minus 4 for x in this expression and wrote the rest of it just as it is. Now now we can solve because we have an equation where we have a single variable. So again, we'll distribute 12, 12y, 12 times negative 4 is negative 48, and then minus 5y equals negative 20. All right, we can combine like terms. 12y minus 5y is 7y. And then we're going to add 48 on both sides of the equation so that that number is no longer on the side of the equation with the y. So 48 minus 20 is 28. And if we want to solve for y, we have to undo multiplying by 7. So that will be divide by 7. And we get y equals 28 divided by 7 is 4. Just confirming y equals 4. That's what we got on our original approach. So when x is 0, y is 4. And we could, if we hadn't done that other work, we could substitute 4 in for y. 4 equals x plus 4. Well, x would have to be 0. Okay? 4 in for this y is something minus 20 equals negative 20. Well, this has to be 0 then. 12 times 0 is 0. So that shows you can solve by substitution, whether you substitute for y or whether you substitute for x. Either way, if you do the steps correctly, you will get this correct solution. That's it.